Hi everyone, we're Group 13 and we're going to be presenting you our Caterpillar case competition. My name is Alyssa Kamelli and I'm a senior studying supply chain management and information systems and information technology.
I'm Danny Rudy. I'm a senior studying supply chain management and marketing.
I'm Michael Chow. I'm also a senior studying supply chain management and marketing.
I'm Seppi Chu, as a senior studying supply chain management and ISIT.
I'm Huiming Zhao. I'm a junior studying supply chain and ISIT. To start with, this is our agenda of the day. First, we will go over the company overview, and then we will talk about the transportation optimization, and then we will present our implementation consideration. To start with, this is the company overview of Caterpillar. Caterpillar is the largest maker of construction and mining equipment. The company has 5 core values, including integrity, excellence, commitment, sustainability, and teamwork. Its current business operation includes 3 parts: machinery, engines, and financial products. Currently, Caterpillar dealers make essential decisions regarding inventory on hand and modes of transportation. These decisions are crucial for maintaining quality customer service and optimizing choices to maximize profit. It is currently hard to know how dealers make critical decisions. Thus, standardized selection practices are needed for better understanding of decision practices and transparencies. Now, I will hand it over to Michael to talk about the transportation optimization.
Thank you. So one of the questions that Caterpillar wanted us to solve was to build a model that can help them recommend either a new form of transportation mode or sticking with the current one. So we decided to solve this by utilizing this strategy. So we went on a store-by-store basis and we decided to come up with an aggregate service level for each store. We did this by calculating a weighted average of the service level based on the monthly forecast of the parts/items that are being shipped to each store. After that, we leveraged the current target service level that Caterpillar provided us with, and we used that to determine either a new or a same mode of transportation. Afterwards, we decided to compare and contrast the current and the proposed new lead time, total cost, and the amount of improvement that we were implementing into the system with our model, and we expressed that in a ratio, which we'll show in just a bit. So to give a visual representation of how our group decided to formulate this model, we decided to do, again, a store-by-store basis or analysis of our previous strategy. So this right here is a screenshot of store 1, and this is just, the first of the 25 stores that we did. And so as you can see here, we took the information that Caterpillar provided us with, and we calculated an aggregate target service level for store 1, which turned out to be 0.9969. From this number, we were able to figure out whether or not we want to change surface to air, air to surface, or stick with the originally recommended mode of transportation. And after doing so, we are able to compare and contrast again the total cost between the old model and the current model, as well as the average lead time for all the parts going to this store, both previously and in our current model. And as you can see for store 1, our suggested model actually gave a 6.01% increase in the total cost, but it came with a 35.89% decrease in the average lead time. On the right side of the screen, you'll see a summary of all 25 stores and how our model will affect the lead times and the spending that Caterpillar is spending at each store. So just to highlight a few big ones that we thought were pretty important to note was store 23, 86, and 89. These 3 stores all had improvement ratios of over 10, which is quite impressive. And that shows that Caterpillar can give these particular stores extra thought when debating whether or not to implement a new system of new mode of transportation.
Now we're going to cover the necessary considerations for proper implementation, including frequency, disruptions, timeline, and risk management. In order to best use this model, we recommend doing analysis on a monthly basis in order to keep up with changing demand. This also allows dealers to benchmark the forecasted demand against the actual demand each month and adjust accordingly. Frequent use will allow savings to be maximized by changing transportation mode as it's needed. In order to make analysis easier, we also suggest writing a macro in Excel to be able to run spreadsheets without such a hands-on approach. A macro will enable Caterpillar and their dealers to run the report whenever it is needed, whether that be each month or even more often. Making it available to dealers also provides a way for them to make standardized decisions in a way that is more easily understood on all sides, which helps solve one of the current issues with dealer strategy.
So, of course, by switching to a different transportation mode, there are possible disruptions that can occur in the supply chain. First off, transportation contracts can be disrupted, and if so, we recommend renegotiations whenever possible. Next, currently there are allocated amounts of workers to handle shipments from each mode of transportation. So if all of a sudden we decide to increase the amount of shipments coming through air, we would need to train more workers to be able to handle this increase. Lastly, we found that weather was a factor to consider when looking at possible disruptions. Ground and air transportations are limited by different kinds of weather, which can be unpredictable. Next, in managing network constraints, we saw that it was best to prioritize the parts whether on importance, lead time, or cost savings of changing the mode of transportation in case we run into the problem of reaching capacity of a mode of transportation. We found that it would also be helpful to keep updated forecasts and to possibly foresee problems and give employees an opportunity to prevent them. By doing both of these, the supply chain can be strengthened.
Caterpillar also wanted us to explore the flexibility of our model. We built a lot of flexibility into our model to account for all of the different countries that Caterpillar is active in. The only two recommendations we would have is that Caterpillar should look at the different transportation modes and the limitations in certain regions, and they should also consider the currency conversion to US dollars so that they are more accurately able to compare their financial savings throughout all regions. This slide is about communicating the importance of the model to the dealers. We wanted to emphasize that by creating visibility, it is beneficial for both sides. If dealers and suppliers are able to release their service and lead time, it can lead to a strong relationship that can in turn lead to a partnership. Partnerships are built by visibility and most likely will save you money in one way or another, and you can work together to build a strong supply chain. Thank you.